Welcome to Precalculus. I'm going to work through an a hyperbola example. This is a new one, but it's one where the center will not have one of its coordinates on the x-axis or the y-axis. Okay. So the first thing first you can tell it's a hyperbola because it has two square terms, but they're different signs. The x squared term and the y squared term have different signs. It's a hyperbola. So what we'll do first is group the x's together, the y's together, put the constant on the other side. I'm going to put the y's first because the y squared is the positive one. And the x's will go second. Make sure it's copied right, looks good. Next thing you do is you must factor out the coefficient of the squared term. Whatever it is, it must go. Unfortunately, 150 divided by 25 is 6, a nice even integer. And we'll add something there. And you factor out the negative 4, and negative 8 divided by 4 is positive 2. Don't forget to make it positive. Negative 8, you factor out the negative 4, it's positive. We'll add something there in a moment. And it equals negative 121, and there'll be some other stuff. So what do we add? Well, if you half this number, you positive 3, square it, you get 9. So that's going to factor out that way. You half this number, you get positive 1. You square it, you get 1. That's going to factor out that way. But you can't just go around adding 9 in parentheses and 1 in parentheses. If you do that on the left side, you must do it to the right side. So did I add 9 to the left side? No, I really added 25 times 9. Like if you distribute the 25 back through, it would be 25y squared plus 150 plus 225, which is 25 times 9. So we have to consider that. Similarly, I added not 1 to the left side, but 1 times negative 4. So I better add that to the other side as well. So let's see, 9 times 25 is 225, minus 121, 104, minus 4, a very nice 100. Divide everyone by 100, and like many of these are set up really nice, that will cancel the 4, that will cancel with the 25, that of course is 1. So our standard form becomes that. Notice the y comes first. That's an indication that's going to be vertical. And we get there. Okay? We're going to finish go on to the next slide here. So next thing is to note what I'm not going to rewrite the equation. I have it on my paper here, but you have it on yours as well. So we can tell by looking at this that the center is going to be at negative 1, negative 3. Not negative 3, negative 1. Remember, the x coordinate of the center goes with the x, the y coordinate of the center goes with the y. Also, this is going to be, is it vertical or horizontal? Vertical, because the y came first. And we know right away a squared is 25. A squared is 4. The a with hyperbolas always comes first, therefore a is 2. B squared is 25, therefore b is 5. And to find c in hyperbolas, let's see, it's the biggest, right? So it gets to go by itself in the Pythagorean relationship. We don't know what c squared is, but a squared we know is 4. B squared we know is 25. So c squared is 29, therefore c is the square root of 29, which I don't have a calculator on me, but I think that's about 5.4, I'm going to guess. Okay, we're ready to graph. Let's go on to a new slide. Okay, next slide here, we will graph, and you have all the features in front of you. I'm not going to rewrite those. So I'm going to need this whole screen to get a decent graph. And I've already tried this once, it didn't work out very well, so hopefully I'll do a little better this time. So negative 1, negative 3, 1, 2, 3, put a dot. That's our center. Negative 1, negative 3. First thing I would do is do the vertices. The vertices are A units from the center. We said it was vertical, so they'll go A up and A down. A we noted was 2. So if you go up 2, you're going to land here at negative 1. If you go down 2, you're going to go down here at negative 5. When I'm done, I might be able to try to squeeze all these labels in somewhere. Next to the B points that I call B points. So I need to go right 5, 1 to the y-axis, 2, 3, 4, 5. Way out there. The other one, 5 to the left, 1, 2, 3, 4, 5. Let's label these. That's 2 and 4. Negative 2, negative 4, negative 6. If you want to find out how far apart are the B points, from negative 6 to 4, that's 10. And 10 is double B. That's good. B is 5. How far apart are the vertices? From negative 1 to negative 5 is 4. 4 is double A. It's 2 times our A, which is 2. We can now make our box. This is going to go... Wow, I really can't draw with this thing. Sorry. There's our asymptote box. It goes through the vertices, through the B points. Then your B points will help you, or this asymptote box will help us draw the asymptote. And I'm going to use a different color. So it's not that big of a deal that these dots aren't that great. Okay. We're ready to graph. Let's change colors. So it's going to kind of come along. This is not good. Yeah, as you know, I'm picky with your graphs. I don't know if I can even draw to my standards with this stylus. That was decent. Then the other one goes along the asymptote, through the vertex, and then along the other one too. That's not great. I probably would have erased that, but it's really hard on here. It should not touch the asymptotes or the asymptote box. The vertices should be minimums and maximums. Okay. Lastly, the focus points were square root of 29 from the center, which square root of 29 is, let's see here, square root of 29 is about 5.4. So that's going to take us from negative 3 down to negative 8.4. 1, 2, 3, negative 7, negative 9. So around there. Let's focus. And if I go up 5.4, I'm at negative 3, so I need to go up to what? 2.4? 1, 2, 3. So it's around there. Okay, everything's labeled. Hopefully yours will look better on paper. But let me do our actual labels as well. So our center is labeled on the other page. The vertices, we found those to be at. I would usually do this as I was going. It'd be the way to do it, but I didn't really know where I would need to draw. At negative 1, negative 1. And at negative 1, negative 5. You can kind of test it. Does that seem reasonable? Same x coordinate, y coordinates, 4 apart. Again, 4 is double A. That's good. Foci, we can squeeze in over here. Foci were at negative 1, negative 3, and then we added the square root of 29. And then we did negative 1, negative 3, and we subtracted the square root of 29. Those are the exact coordinates. And that does it. I think we got it done. We label our foci. We have dots on the graph for foci, vertices, center. foci, vertices, center all have labels written on our paper, or at least on my previous screen. The asymptotes are there. The graph doesn't touch the asymptotes. Looks pretty good. Hope this is making sense. See you next time.
Made with Doodlecast Pro.